Hey everyone, Matt Donner, Chief Academic Officer at Pyramide here. I'm going to do a very simple Audio Fundamentals 101 video on a very interesting but sometimes confusing subject known as phasing, summing, and beating. The three different phenomena of what happens when two different sine waves interact, whether they're at the same frequency or not at the same frequency, and different kind of things that can happen. We're going to start this one first with what happens with two sine waves. We're going to show them first summing and then beating at a few different frequencies. And we're going to start with two sine waves, the first one being 110 hertz, and then we'll start adding other frequencies into the mix. Again, beating is what happens when two sine waves interact, and if you want to think of them as kind of two waves dancing, when they're in sync, it means they sum, and when you look at them side by side, they do this, but when you add them together, they make one big wave that goes twice as loud. So that's summing. And then beating is what happens when two waves, one's just ever so slightly faster than the other. They kind of start off in sync, and then they slowly fall out of sync, and then eventually they're sort of opposite, and then eventually they come back together in sync. Kind of like windshield wipers on a bus. If you've ever seen them, they sort of start working together, and then they sort of slowly fall out of time with each other until they're going opposite. Same thing is going to happen here. We're going to start with 110 hertz. And we're going to slowly add in some other frequencies. So just to show you what I'm working with here in Pro Tools, this is something called signal generator. And signal generator is pretty simple. It literally creates a variety of different types of waves. We're going to start with a simple sine wave. I'm going with negative 6 dB, just have a little headroom, and you can see plain as day. It is 110 hertz. Now that's what's going on in this first track. This is what 110 hertz looks like and sounds like just on its own. Simple enough. If you want to check it on the piano, you should find that it's the note A. Okay, now over here, oscillator number 2, you can see I have it at 111. I'm going to change that to 110. So now what we have are two sine waves, each at negative 6, both panned up the middle, both going to the same output, and we'll start with this particular meter. Actually, I think what we'll do, we'll start with this particular meter. And so what we're going to do is we're going to measure the volume. You can see here that I have it set to peak. I have it calibrated to negative 6, which means that the 0 mark here on the VU meter is going to measure 0 when the volume hits negative 6. Okay, so we'll start with something simple. Here's 110 on its own. And you can see that each of the left and right is measuring negative 3. The reason why it's measuring negative 3, even though the signal generator says it's pumping out negative 6, is that that negative 6 is getting split into the left and right channels. So if you remember from the Haas effect, when you take a single signal and you split it across two speakers, each speaker loses 3 dB. If I were to take this and pan this hard to one side, for example, now it's on the left, all of that signal goes to the one channel and it's now measuring 0, negative 6. Same thing if I were to go to the other side. Okay, so we're kind of doing two things at once. We're showing the Haas effect, negative 3 dB, and we're going to talk about beating. So now what happens if we add another negative 6 at 110? Simply by turning this on, you can see the meter got louder, and what I'll do is I'll give you a peak indicator here. Okay, so with the one signal, actually let's lose that. So you can see with the one signal, we're measuring negative 3 on either side. When we add that back in, we get another negative 3 push that also gets split, which is why each side is measuring 1.5 dB. Now that's simple enough. That's also just the volume. Let's take a look here at this pretty meter. This is called the phase scope. And what you're looking at is a combination of volume and phase. Now with this going vertically up and down, and this pinged all the way at +1, it's visually telling you that the signal is in phase. That means the two waves are exactly the same, and they are both going the exact same time. Now, what happens if we take the second signal, change it from 110 to 111? So your ears are telling you that it's kind of beating. It's going up, and down, and up, and up, and down. If we look at the phase scope here, even though here it's telling you it's perfectly in phase, This isn't really true. You can hear that it's beating and summing, but what we're measuring here is actually the stereo sum. So the two, after phasing, or after beating, is coming up in phase. Now watch what happens if I pan the one to the left and then the one to the right. Now you can really hear the beating. What's going on is that the left signal is at 110. The right signal is at 111. And so now what you're doing is you're literally watching them phase in and out at one phase cycle per second. The difference between 110 and 111 is obviously 1 hertz, or 1 cycle per second. So you're literally watching the two signals phase in and out over the course of a second. The signal doesn't go away here. Notice the meter is the same, because we are getting unique information, 110 in the left and 111 in the right. So each speaker, each channel has unique information. When we pan these both up the middle, you no longer see the interaction in phase, but you see the interaction in volume. A really good way to take a look at that is through this really cool plugin I just checked out. This is a demo version. You can get it for free for a couple of days, or you can get it paid for from Blue Cat. I'm pretty sure it's just Blue Cat's website. You can find a free downloader. Now look at this wave. What you're seeing is the phase cycle in and out of 110 and 111, both in mono up the middle. The meter goes away for a minute and then it comes back because it's in demo mode. Now you can see the sine wave getting twice as big and then down to 0. That's as it sums and phases in and out over the course of 1 second. If you want to take a look at it another way, I'm going to go back to panning these left and right. So you can literally see how the orange and yellow lines go back and forth between lining up and splitting apart. When they split apart, they cut the time in half and then they come back together to sum. So when they're together, they're summing or adding, and when they're apart, they're phasing, creating this volume beat. Okay, so that's basically what happens when two waves interact, that they're not the same. I'll take this one step further, and we'll go from 111 to 112. Now what's going on is the exact same phenomenon, except twice as fast. Because the difference between 110 and 112 is 2 cycles per second, it's going to phase in and out twice per second. So that's why it's going twice as fast. Now, if you want to look at it this way, you're not going to see very much. But when you see it this way, you can see the volume dancing in and out as they go from summing to phasing, summing to phasing, summing to phasing. You can also look at it here, better yet here. You can see the volume is beating twice as fast because now the two waves are 2 cycles apart. And again, if we pan them left and right and have unique information in each channel, you can see the beating down here going twice as fast. And when the line goes from up and down to side, that's the difference between it being in phase and out of phase. So really good meters to help you check whatever's going on in your music. If something doesn't sound right, you should always take a look through one of these meters. And if this guy isn't in the positive section, you've got a problem. Okay, so that's the basics of phasing and summing and beating, just shown here with 2 different frequencies. And you can do this up and down and up and down and up and down, as many frequencies apart as you like. When I crank out the next video, we're going to go in and show you what happens when you add 3 or 4 frequencies together, and then what happens when you take lots of frequencies together in phase scope. Until then, it's Matt Donner, Chief Academic Officer at Pyramind. Hoping you enjoyed this.